Okay, so today we will start. I will take your attendance later, but I will see the last picture and come to very hot. All of you, why you are going there? It will be easy for me to interact with you. So please come, make available yourself on the first bench. Wait. All of you, please last bench. Why you are hiding? Okay, so in the last class, we draw this waveform, and I told you I have no invitation card for you. Next time I will prepare. Yes, come in. All of you, please come. You also. Come to the first bench. You two guys, why you are there? Come to the first bench. Fan is also switched off there. Not audible. You are saying something. Okay, so as I told you, all of you please concentrate here. So this waveform I told you that is it correct or wrong? The clipper circuit, I think I said something. So this one is a correct waveform. Clipping wave, sorry, it is a clamper waveform. Yes or no? This one is the correct clamper waveform. Yes or no? Okay. So now look at here, all of you. What I told that clamping means the shifting of the waveform either in the positive side or either in the negative side. So if you think about this one, so it is a shifting of that waveform to the upward or to the downward. Got my point? So now look at here, we got the waveform from T1 to T2. So we will check that from T1, I'm sorry, this is T3. So from T1 to T3, I have this waveform. So we need to check that is it the correct waveform or not. So now look at here, what is the voltage level over here? It is -20. And what is the voltage level over here? It is 10. So what is the voltage differences between this one and this one? Voltage difference 30 volt. Correct? Now we need to minus will not be there. Now we need to check that what voltage we are getting over here. Now what is the maximum voltage we are getting? Can anyone? What is the maximum voltage we are getting? 35 volt from this equation. And what is the minimum voltage we are getting? 5 volts. So what voltage we are expecting between these two? We are expecting 30 volt. Correct. So T1 to T3. Now look at here. So T1 to T3, I am getting a 33 voltage of the fix. So that means it is starting from here, stopping over here. So that the things is correct over here. Got the point? So this is a simple explanation of the clamper circuit. Now today I have some more circuits over here regarding the clamper. So what I will do, I will share all the small circuits which I have to perform as I shared in the last class. You need to perform each and every circuit with the analysis that are you able to solve or are you able to get that waveform, yes or no? Got that point? Clear? Now today what we will do, we will start from the regulator circuit. So regulator circuit. What do you think about the regulator circuit? Any idea? Any idea what do you think about the regulator circuit? Which component we are expecting for the regulator circuit? I think we know that what are the circuit components for the clipper circuit? Can you please tell me what are the circuit components for the clipper circuit? Diode, resistor, clipper circuit or clamper circuit? We are talking about the clipper circuit. Diode, resistor, input voltage, source voltage. And for the clamper circuit, diode, resistor, capacitor, and source. And for the rectifier, we need one special type of the diode. Okay, till now we are using the junction diode. Now we will use the J0 diode over here. Correct? For the rectification operation, we need J0 diode. And I hope that you already know the fact. You already know the fact that what is J0 diode. Correct? So I already discussed about that. J0 diode is a diode, is a heavily doped, so that we can get a huge amount of the current on the reverse bias voltage. Correct? Got the point? As we saw that the avalanche breakdown will occur for a single diode, simple diode, when a reverse voltage will be on the reverse breakdown voltage. So avalanche breakdown will occur at that voltage point. So what is the avalanche? At that voltage, we will get a huge amount of current. Correct? So that is actually here we are using for the same thing. Now look at here. This is the J0 diode ideal condition. Okay. So at the forward condition, we can see that this is the voltage 0.7 volt if the J0 is made by the silicon material. Okay, so that means J0 diode is a special type of diode, but when it will be on the forward bias, it will behave simple as the diode is behaving on the forward bias. Got the point? So what is the difference between J0 diode and normal diode? For the forward bias condition, if the materials are same for both of the cases, it will behave in the similar way. Now look at here on the reverse bias condition for the J0 diode. Okay, so now we have a J0 voltage over here VJ. This is created because of the heavily doping condition of the J0 diode. Now on this voltage, okay, so on this voltage, we are getting a huge amount of the current because this y-axis is the current of the diode and x-axis is the voltage to the diode. Correct? So at the breakdown region, so this is my breakdown region, J0 breakdown region. Which breakdown region? J0 breakdown region. So I am reaching to the J0 breakdown region and I'm getting a huge amount of the current. Is it visible to you? Yes or no? Yes, is it visible to you? If you look at the graph, we can see very clearly. Look at the blue curve. So we can see that this is actually the curve which is actually we are expecting from the J0. Now the question is that avalanche is done or not for this characteristics curve. Avalanche voltage is done if I reach to the VJ, or it will be more than that or less than that. If I am talking about the avalanche voltage, anyone? Less than VJ. Yes, less than means we are talking about this side, correct? So if I am talking about the avalanche, we need to give more reverse bias voltage to reach to the avalanche, and at the avalanche reverse voltage, the diode will no longer means useful because it will burn. Correct? Got the point? So we are using the diode in a tolerable range on the reverse bias for the huge current. Now look at characteristics, try to understand. Based on that characteristic, the next circuit analysis will be there. So be careful about that. And things are very simple if you understand. Now look at here. If I will point my reverse bias voltage on the green marking point, so my diode, the J0 diode will on or off. the Zener diode will off. Why? Because look at that. What is the voltage? The reverse bias voltage I am getting. What is that? That much of voltage I am getting. But what is the current flowing through the diode? It's zero. The current is flowing through zero because ID is this one. Current flowing is zero. If I will give the reverse bias that much amount to the Zener diode, still the same condition. When I'm giving this V rate voltage, reverse bias voltage to the Zener diode, then I'm getting a huge amount of the current over here. Okay, I hope this characteristics curve is very clear to you. When we are talking about the Zener diode, we are talking about the reverse bias characteristics, not the forward bias. Forward bias as usual to the diode as the normal PN junction diode. Is the point is clear? So what does it mean? The meaning is very simple. When we will use the Zener diode in the circuit operation, we will use the reverse bias, we will use the reverse bias condition of the Zener diode so that we can get a huge amount of the current, and that huge amount of current is very much suitable for the voltage regulation. Do you know what is the term of the voltage regulation? Any idea? Voltage regulation.
Increase the voltage if there is low voltage, or decrease the voltage if there is excess.
Actually, if you have the DC output source, suppose you have a DC output source, correct? 55 circuit you have. You want to maintain the voltage constant level. I need for my mobile 5 volt 1 ampere current. So I need to maintain that current and voltage across the mobile charger. Okay. See, if I have the one circuit over here, I'm not willing to draw. Now this is my load. Okay, RL. I want to maintain the current over here and the voltage across this resistor. How it is possible? Because if I change the resistance value, this is my load, okay, and I can change it. Right now my mobile is there. I can use some other devices for charging up on the same voltage and ampere. But the load operation, the load of the mobile, output load of the mobile and output load of the another device will be different, correct? Then the voltage and current rating will not be same for that source. How to make the VL and IL will same for almost all the devices? Then this device, this semiconductor device will help you. Zener diode will help you for that case. Got that point? So voltage regulation means your output voltage, the load voltage, and the current will be the same or fixed. So you are changing your load resistance. Load resistance changing means you are changing the load. Different load, but still VL and IL will be same. Got that point? Yes or no? Is that point is clear up to this point? Now we will go to the regulator circuit quickly. What are the analysis and circuit components are there? The very simple things are there. Not very difficult. Let me take you over here. Now, when we are talking about a regulator circuit, simple circuit is there. What are the components? Look at here. Major components is required, that the Zener diode. But I forgot to tell you one more point on the Zener diode. When we are talking about the Zener diode have some specification. What are those specifications? Can anyone please tell me what are those specifications for the Zener diode? When we are talking about the Zener diode, the simple major specification for the diode is there. What are those specifications we are expecting? It is already given over here. Look at here. The voltage, the Zener voltage is the major one. Why? Very simple. Go back to the previous one. Zener voltage, which region we are expecting from the Zener? Reverse bias voltage region. So we must have the idea that what is the reverse bias voltage, Zener breakdown voltage, so that we will get a huge amount of the current. Because that is the region where we can, this is the region where we can utilize for the voltage regulation. So we need to reach to this voltage. Is that point is clear to all of you? So when we are talking about the generator, I'm coming to the symbol later. So the BJ means reverse breakdown voltage is important for us. What is the current of the generator? That is also important. And another rating you will see that this is the rating P of Zm. Can anyone please abbreviate this code? What is that of Zm? Anyone? Any idea P of Zm?
Maximum general power.
Yes.
Maximum power.
Maximum
Power.
maximum power. Very good. It is a power of the device. So when we are talking about the power of the electronic devices, so what we will do? V and I. Is it clear for all of you? So voltage and current, when these two will multiply, we will get the power of that source or whatever the things you want to say, but it will be V and I. Now the power of the Zener diode, the rating of the power of the Zener diode will be given the body of the Zener diode. Got the point? And the voltage rating will also be given on the Zener diode body. So you will see two more parameters. One is that power of the Zener diode and the voltage rating. So when you're talking about the voltage rating, which voltage we are talking about? No, which voltage we are talking about? No, not average. Average means yeah, or we use the code. You? VJ? Definitely. But what is VJ? That is my question. Breakdown voltage. What is Zener voltage? Zener can get forward bias voltage. Zener can get reverse bias voltage. Which voltage it is? VJ. Yes, you got that point. Can you add some more points after VJ? That's good. It is a Zener reverse bias voltage. Where we will get the breakdown. Correct? So it is a VJ, and for that VJ, what maximum current we are getting, that is known as a Zener current. And we will write it the maximum of this. Got that point? Yes or no?
Yes, sir.
Clear? Now, what is the circuit analysis we are expecting for this one? Now, we have three conditions when this circuit will be there. I forgot to tell you one more point. Now, look at here. This is what? This is what? Simple a triangle. Now, this is what? This is diode. And now look at here. Now tell me, this is what? Symbol of the Zener diode. Got the point? This is the symbol of the Zener diode. So we will use that. This is the symbol of the Zener diode. But when we are using this simple circuit, look at here. This simple circuit will be beneficial for us to create a stable output voltage with a stable current. And what we are expecting at the input side, should we give some voltage to that circuit, or it will be a cascade way of a circuit component? So what is the VI over here? Can anyone please tell me what will be the VI over here?
30 volt.
Yes?
230 volt AC.
30 volt AC. What is that? Input voltage. What kind of input voltage and from where we are getting this voltage? That is important. VI is the input voltage. Very good answer. But from where we are getting that input voltage? We are sourcing that input voltage to this circuit, or we are using some circuit elements so that we get that one. Anyone? Transformer? No. Anyone? Yes. Okay. Rectifier. So the output of the rectifier, filter one, we will tap it over here. So once we have the rectifier circuit, okay, then we need to filter it, okay. Then we need to regulator circuit, regulate it. So this input is actually we are getting from the rectification after rectification operation, after filtering operation. Got that point? Very good answer. So now this circuit analysis, what we will do, we will analyze on three different conditions. So what are those conditions? So quickly I'm going to those conditions. I have the equations, but I don't want to use those equations. Okay, let me explain quickly. Okay, forget about those things. I will explain, then we will come back to over here. Now look at here. What is the condition? Regulator circuit. Three situation, as I told you. This is the first situation. What is that situation? VI. What is VI? Input voltage and R is fixed. So VI and R. This should be RL. Correct. VI and RL. This one and this one are fixed. Then what will be the analysis? Got the point here? Now look at here. How to analyze this circuit? Important point. Circuit analysis is very simple. Okay, important point is that how to analyze. Oh, you asked me the question for the important question. We'll take it. I will share someone actually asked in the WhatsApp group that shared the important questions. I will do that one. Previous question. That questions I will share. That will act as a important question. Some of the important questions. Okay. Now look at the analysis. How we will do? We will start. First, we will consider that there is no zener is present. Simple. We will remove the zener from the circuit and we will analyze the circuit. So what does it mean? Simple. The meaning is this one. No, short करेंगे तो all the currents will bypass through that one. So VI is fixed one. This is my RL. This is my A and B point. I am considering throughout this analysis A and B point over here. Okay. And this is my R. And this is considered as a VI. But for this case, it is constant. So I can consider V. Is there a changing voltage? We will use VI. Correct. So now we are considering V volt over here. Don't confuse that V and V volt. Okay, so if you write V volt, you will see it is a V and something goes on. So be careful about that one. Okay, because it is written, so that's why I need to use that one. So V is there. Now one current will flow through this circuit. Okay, one current is flow, and I consider that current is I, and I need the current of IL. What are the necessary things are required? Look at here. I need the zener current. I need the load current over here. And I need the input current I over here. Is that point is clear? Sometimes it is written IR. So I am using it is IR because this current is flowing through this series resistor. So I will mark it as a IR. So instead of writing I am writing IR over here. I hope it is clear to all of you. Got that point? Now analyze this circuit. We need to find out the voltage across A and B or across this resistance RL. So what voltage we will get? We will get VL voltage. So what will be the VL value? Can you please tell me what will be the VL value over here? Huh? What will be the VL value and how can we get the VL value over here? Voltage division rule, or we can analyze the circuit very simple way. So we will get that. So what will be the analysis? Now look at here. The analysis. Now look at here. So V is there. This is plus minus. Current is flowing in this direction. Current is flowing in this direction. So what we will get? V minus IR into R and minus IL into RL is equal to 0. Yes or no? Now for this circuit, all the components connected in a series way. So what we are considering, we can consider that this one. Can I write that? Look at that. I am writing IL is equal to IR because it is in a series. In this circuit, all the things are in series one. So now on the next case, what we can write, we can find out the IR that is required actually. So I'm doing the things directly, you can understand. So R plus RL. Got it? Now what voltage of the VL we will get? So VL will be IR into RL. So if I will do in that way, so what I will get? I will get R plus RL into RL. Got it? Can I get this one? where Vi is equal to V, I'm considering this one. So the first equation I got in that way. Here, try to understand the circuit operation and circuit analysis. So this is my post analysis of the circuit. Now if I go to the next one, okay, so I got this one. So I got the value VL is this one. Why this operation is required? Why we removing this Zener diode? Can anyone please tell me why we are removing this Zener diode and finding out the voltage? Actually, we are finding out the voltage across A and B, which was the position of the Zener diode. Look at here. This is the position of the Zener diode. We are removing first the Zener diode, analyzing the circuit. Why we are doing that one? Yes. Parallel may have, but why we are removing first? Any idea? Figures? Huh? Okay. Any idea? Anyone? Anyone? Look at here. This Zener diode have some rating. What is the rating? The voltage. At which voltage it will give you the maximum power. Right? So I need to find out the rating of the generator from the market. Different voltage rating are available for the generator. Got my point? Different voltage ratings are available. For my RL, for my load, which generator is required? First, I need to understand that thing. Once I will know the voltage across A and B, then I will purchase one Zener diode which is suitable for that voltage. Is that point is clear? Got my point?
Yes, sir.
If it is not clear, you can tell me. If you are not telling me, then I will give you one numerical for it. It's very simple. I will come back to this slide again, but this point is important, and throughout the circuit, other operations also, you will see that kind of thing. So all of you, please try to solve this one. Sorry, this problem. Now look at here. For the first, you need to look that which voltage. Problem statements I'm not willing to give it to you. Problem statements is there, but look at here. My V is fixed over here, and RL is fixed. Can we say that RL is fixed? Can I say RL is fixed? Yes, madam. You can you please stand up? Can I say the RL is fixed? Yes, mine. RL is fixed. RL is fixed or variable? Why you are saying that? Oh, supposing. Identify this symbol. What is that? What is that? Ah. Yes, you are correct. Sit down. This is a variable resistance. So RL is fixed. Why? Because this variable symbol is no longer there. RL is fixed. Simple. Done? Got the point? So my V is fixed because it is a DC source. How can I change this one? Simple. And my RL is fixed. Why? Arrow is not there. Simple. That means it is no longer variable. Solve this problem. So what you will do? First, you need to remove this. Okay. Which one? Which one you need to remove? Zener. Okay, that's good. You need to remove the Zener first. Have you removed that? Where is your copy? Open your copy and solve this one. And tell me the voltage across A and B. All of you, please solve this one. This type of problem definitely will be there in the next semester. So please do that one. If you have any problem, you can inform me. Try to solve this one and get the voltage. Remove the Zener first. Analyze the circuit. Find out the voltage across A and B, and tell me what will be the voltage when your RL will be 1.2 kilo ohm and R will be 1 kilo ohm. and the voltage will be 16 volt. Don't think it is a capacitor. It is a voltage source. Okay. Can you see the generating over here? We will see later on. Okay. Those are seeing online. This is suppressed. Okay. Nothing is there. Solve this one. 8 point. Okay. So I got a voltage. I don't know it is correct or wrong. So VAB 8.7 voltage. Is it correct? 8.7 voltage. Now look at here. I need to take you to the general characteristics. Now look at here. My general is over here. This is over here. And this is over here. What voltage this is? VA. Correct? What current we are getting right now? So what voltage we are getting means when we will analyze the circuit, 8.7 volt. Okay, across this one. So look at that. This particular component circuit element is on the reverse bias or is on the forward bias. It is on the reverse bias. So that voltage is actually given to the diode. Means we are talking about 8.7 volt over here. Why? Now look at the specification. What voltage has given over here? Generating 10 volt. What we are getting? So diode will act. Diode will on or off? Diode will off. So if we will give this amount of the RL, I will not able to active the Zener diode if we will use 10 volt Zener diode. So for that, we can do two more things. Either I can increase the resistor, I will give you that problem. Otherwise, I can change the Zener with the rating of 8.7 volts. Is that point is clear? Okay. So hope it is clear to all of you. Now look at here. This particular resistor is not suitable. I have another resistance value for you. Just let me take that resistance value. 3 kilo ohm. So instead of this one, use 3 kilo ohm now. Okay. 3 kilo ohm and find out the voltage VAB now. So this VAB is for 1.2 kilo ohm. Okay. Now 3 kilo ohm, what voltage we are getting? Yes. You can yourself repeat that. Now the resistance value is 3 kilo ohm. You need to find out VAB again.
11.4.
11.4.
11.4.
Let me check the circuit. 1 kilo ohm is there. 11.4.
Yes, sir.
Sure about that? So I'm getting voltage 11.4 volt. So at which point? So my VZ is 10 volt and I am getting the voltage 11.4 volt, which is somehow over here. So my diode is on or off? On. Now my diode is on. Because it is more than the VZ voltage. Got the point? Is that point is clear to all of you?
Yes, sir.
Okay, so what voltage we are getting? 11.4 volt when we are using 3 kilo ohm resistance over here. Okay. Hello. 16 minus. We can take. I can use this previous one. This equation. Can I use that equation? Do you remember? Maybe no. Yes. So VL is equal to, look at here, VL means that VAB, V by RL plus this one. So I am using this one. So VAB, which is equal to VL also, is equal to the input voltage divided by load resistance. Now it is 3 kilo ohm divided by 1 kilo ohm plus 3 kilo ohm. So what will be 4446? They are correct. They are continuously telling that it is 12 volt. This is 12 volt. Thank you for questioning me. Okay, so I got that 12 volt. Is it okay? Correct. Yes. So 12 volt is there. So still it is 11 or it is more than 10 volt means my diode is active right now. Very good news. Now I need to find out the IZ value. IZ. My IZ. What is IZ? Current across zero. Okay, it is the general current. We know this is the current of IR or I, whatever you want to say, because R is there. So we can write IR. IR is there. IR is there. So IR is equal to, look at that. This is my IZ and this is IL. I hope you have the circuit understanding. Okay. Now you need to find out IZ. Tell me the value. What is the value of IZ right now? So we already know the value of IR if we are able to calculate that, and then subtract the IL value. What is the IL value? How we are able to find out the IL value over here? First, you need to tell me how we are able to find out the IL value. Yes. When diode is connected, V8. Sorry. When diode is connected, we will write it is V8, and we can replace when diode is on. Important point, when diode is on, we can replace this diode by a simple reverse bias battery, which is having the voltage V8. When diode is on, we can do this one with the diode. We can replace the diode. So what is the function? First is that first we need to remove the diode, inner diode. Analyze the circuit, find out the voltage so that the desired zener will be there. Once you have the zener, once you have the okay. Now BL is there. So this AB means it is a voltage across the zener we are expecting. So this is the zener voltage. That's why we are writing VL is equal to VZ. Is that point is clear? Yes, I can explain this one, but I want to explain this one on the next slide. Now look at here. Look at here. My VL. Now look at here. Across this point, A and B, my zener voltage is fixed. What is the zener voltage? The zener voltage, it is plus minus, it is VZ. Now this one is parallel with RL. The zener is parallel with load resistance. So the voltage of the load resistance will be equal to the voltage of the zener. So I can write VL is equal to VZ. Is that point is clear to you? All of you? Is that point is clear? You're not listening. Don't tell me live. Okay. You're not listening. All I think is something. But if I ask you some question, I'm damn sure that you will be able to give the answer. Is that point is clear? So what are the things are necessary for you? Remove the diode, find out the output voltage, put the diode, find out the zener current. And once you have the zener current, OTIPY, OTP spam, something like that. So P8 is equal to, so P8, so the P8 is equal to, then need to find out VZ into IZ. Okay. So once you have the zener current, now look at here. Once you have the zener current, now you are able to find out the voltage over here. Is that point is clear? Situation 1 is clear. Now you have the situation 2. I am giving the situation directly with you as a problem statement. Now tell me what is happening. What kind of situation is this? You. What kind of situation is this? Variable resistance. And what about the input voltage? What about the input voltage? U. Constant. So the situation is very simple. You need to find out the range of the voltage. Okay. So what are the designing equations are there for that? Because I have lesser time, so I keep all the equations over here. Now look at here. This condition, the second condition, fixed VI, variable RL, and this will be this one. Fixed VI, variable RL. What are the process? Process is same. First, remove the diode, find the voltage across this one. Okay. Then place the diode with the reverse bias condition with the voltage VZ. Okay. So then you will get but you need to remember this point when you are examination hall. No need to bring your phone. Okay. Now look at here. So once we will remove the diode, we will analyze the circuit. We will get this one. This is the designing equation. We saw this designing equation over here. This is Elon Musk. Okay. So automatically this is taking. I don't know. So this is the equation. This is the basic designing equation of the generator. Do you believe that? Do you believe this is? Do you believe that? Do you believe that? This is not your question. Wait. Do you believe that? So you need to concentrate here more. Okay. Got it? No, not that point. Okay. Sorry. Now look at here. Listen, because this type of problem will be definitely you will expect. Then you will think about that at least I told you to remember this one. Okay? Not the point? Yes or no? So what is this one? What is this one? Equation of real. When we are getting this one from the basic circuit after removing the diode. Simple. Correct? Look at here. Now come to this problem. So this is the basic equation, designing equation for the regulator. What they are asking about that variable RL. It means that from minimum RL to the maximum RL. Okay. So what is the tolerance for that? We need to determine that one. So for that, we need to find out the RL with the minimum value for which the diode is on. Let me take you to this problem where we did this one. Now look at here, concentrate over here in this particular point, very important one. When we have the 1.2 kilo ohm, the diode is not on. Correct? In this case, and the diode is on? No. Now when we are increasing the resistance value, though from jumping from 1.2 to 3, but we are increasing. When 3 kilo ohm is there, now we can see diode is on over here. So at what resistance value, minimum resistance, for that the diode will on? That is the R minimum. Got the point? So what is the R minimum over here? So R minimum over here, it means that what minimum resistance value will be there so that my diode will start conducting. Okay? Can you please tell me? I have another question. Which type of diode we are talking about? Okay. So we are talking about generator. I'm giving the answer to you. Okay. So this is the thing. Is that point is clear up to this one? Okay. Now this is my R RL minimum. When RL is minimum, can you please tell me what is the condition of the IL? When RL is minimum, what will be the condition for IL? IL will be maximum. Why? Voltage is constant. Why voltage is constant? I got you.
It's a source is separate.
Huh? Source? No. Source. Jenner has the fixed. Yes. Jenner has the fixed voltage. RL is over here. That's what. Correct. So when RL is minimum, IL is maximum. And when RL is maximum, IL is minimum. Do you believe that? Yes or no? Is this point is clear to all of you? Because the voltage VZ is VL is equal to VZ is equal to IL into RL. If you understand this equation, you will see that for a constant voltage, okay, when IL is minimum, RL is maximum. When RL is minimum, IL is maximum. Because the voltage is constant. And voltage, why voltage is constant? Because we are fixing the Jenner across the load. Voltage of the Jenner is fixed. So we are expecting this. Got the point? Clear? So from using this one, so how we will get this one? Simple, you need to derive this equation. So VZ, now look at here. What actually we are giving? We are giving VL is equal to VZ. Jenner is parallel with that circuit. VL is the load, VZ is the Jenner. Now Jenner is parallel with the load. That's why VL is equal to VZ. Do you believe that? If you don't believe, I don't know. Okay. So now look at here. VZ is equal to RL into VI. Okay. Then it is RL plus R. So how can I get my RL over here? We need to determine the RL value. So RL, we can do it in a different way. So we can. Is it taking the voltage from me? I can't. So now look at here. So VZ by VI is equal to RL by RL plus R. So VI by VZ will be RL plus R by RL, which will be 1 plus R by RL. So therefore, what will be the RL value? The RL value will be VI minus, VZ by VI minus VZ. And this will consider the minimum value of the RJ. Why? Because look at here, just we are considering the voltage across the Jenner is the voltage rating of the Jenner. We are considering the voltage across the Jenner is the voltage rating of the Jenner. So that's why. Now the power rating, maximum power rating for the Jenner is PZM, which is equal to the VZ into I of ZA, maximum current flowing through the Jenner with that voltage. When the maximum current flowing through that Jenner, that means when IZ max is there, it means for that condition, I can get IL minimum, which will gives you RL maximum. हाँ एक R मल्टीप्लाई होगा नहीं तो R कैसे बनना ठीक करेक्ट. Is that point is clear? Solve this question very quickly. Solve this question. Find out the minimum RL. RL minimum. Okay. For the diode on, then find out IZ. Okay. For this condition. Okay. Then find out IZ maximum. And then find out IL RL max. So then you will get the range over here. So Please quickly do that one. Got that point? How to solve that one? I will take tomorrow one class and day after tomorrow one class, and on Saturday one class is offline.
Tomorrow is Monday.
One class is physically here. As far as the timing of the routine, I don't know.
Circle class in
Maybe online. Solve this one. So to our class, you need to give it to me at least, so that the small portion from the transistor I will be able to cover. Huh? अरे वो कहाँ गया? Absent, absent. चला. ये क्या हो गया?
Sir, Windows plus P.
लग तो रहा है वैसे ही कुछ होगा. हाँ? So the VL is equal to VZ is equal to, what is that equation? RL by R plus RL into input voltage. Now RL minimum we already determined from the last equation. What is the RL minimum? Hey, where do that? Oh, this one. Oh, yeah, I did that. So RL minimum is which one? VZ by VI minus VZ. So RL minimum is VZ by VI minus VZ into R. So what will be that value? So VZ, yes, VZ is, we already know 10 volt. It is 50 volt minus general voltage into R is 1 kilo ohm. Okay, so that will be the value. Got a point? R minimum. Now, so what will be the current? What will be the current then? VR by R, but what is VR? So what is VR? We can easily take this one. If it is VR, this is across 10 volt. Okay. So what will be the current IR then? IR will be VR by what is the VR by I now? Oh, VR by 1 into 10 to the power 3. And what is VR? 50 minus 10 divided by 1 into 10 to the power 3. So 40 by this one. So it will come into the milliampere, 40 milliampere. IR is 40 milliampere there.
Sir, we can also use this.
We can use that. We can use. This is the way of the circuit analysis. And this is actually we are using KVL now. So this voltage, this one will equal to 0. Then what will be here? This is KVL actually. Now what is the IL? So IL, I need IL minimum. Okay. What is IL minimum? R is minimum. So IL max will get. we will get. So IL max is what then? 10 by voltage by across this resistance RL minimum. Okay. Then we will get IZ. IZ is what? IL plus IL minus IR. Yes, IR minus IL. So this one. Okay. And this is actually the maximum value of this. So 40 by 1 into 10 to the power cube minus IL max is what? IL max is what we are getting. IL max. Why we are getting? Oh, 10 by RL minimum. So if you will solve this one, you will get the value. Okay. On the similar way, IZM we need to find out. So what is that? Power rating has given. IZM is already given 32 milliampere. So no need to find out 32 milliampere. Okay. And if we use 32 milliampere, from that we can find out what will be the RL max. Okay. Okay, almost done, but want to share how you will represent the thing. Only one portion has left over here. That is the third condition. And the math class?
Yes, sir.
That's the problem. So this is the thing actually. Okay, I'm unable to do. You can see. Just I need to give the comparison over here. This is the VL. This is the IL and RL. So I told you that you need to determine the lowest RL to the maximum RL. So this will be the lowest and maximum for the 10 volt, and you need to find out the VL current. So lower current to the maximum current. So already have that equation. Just you need to find out. You will get this kind of thing. Is that quite clear? So tomorrow at 11 a.m. online virtual mode. Day after tomorrow also. At 11 a.m. I will take one more test, and Saturday one physical test for this. Okay, 3 consecutive things will be there. Okay.
Saturday test होगा.
Saturday test is compulsory.
You आप आओगे, हम क्वेश्चन पेपर डिस्ट्रीब्यूट करेंगे, आपको लिखना है.
क्वेश्चन से बना सकते हैं.
One hour का टेस्ट है.
मंडे को पेपर है.
मुझे काम करने का कोई फायदा नहीं है. आपका 2 घंटे आपका ही फायदा है.
सर जो क्वेश्चन पता चल जाएगा.
एक घंटे का क्लास है. अगर सैटरडे कोई भी क्लास आपका ऑफ है मॉर्निंग सेशन में, आप बताओ, आई विल टेक दैट क्लास. आप आओगे क्लास से?
सर आज ही का टाइम टेबल है सैटरडे. सर 8 से 2:30 बजे तक पूरा पैक है.
आज से सैटरडे आओगे क्या?
सर कोई नहीं.
मेरी क्लास में आना. Because offline है तो at least you need to attend for 30 minutes for that. आप आओगे, एग्जाम दोगे, चले जाओगे.
सर बाकी कुछ ऑनलाइन होगा. बाकी कुछ ऑनलाइन होगा.
I don't want to take the online because you will be the offline.
सर मैथ
I saw listen. I saw your copy, assignment copy, and I found that this is the worst situation ever I saw. I'm seeing this. I saw that one because at least 4-5 copies we are expecting. Single copy. One master copy is there, and each and everyone they are copying. And the person, you know, she told me that ये मैंने बनाया है, बाकी सबने कॉपी की.
सर मैंने मुझसे
I will share all the question papers all the materials on the remaining platform. कॉपी अरे हाँ किलो का कॉपी चेक करना है Okay, my class is over. You can relax now.